All right, so I think this is recording. Let's take a look at this word problem. It's we're working with work problems. So here we have a cold water faucet can fill the bathtub in 12 minutes, and a hot water faucet can fill the bathtub in 18 minutes. The drain can empty the bathtub in 24 minutes if both faucets are on and the drain is open. How long would it take to fill the bathtub? Okay, so our unit of time is minutes. We've seen problems where our unit of times was hours, and in the last problem, the previous problem, it was days, and I almost started to accidentally work with it in hours. All right, and right this time we have the the two faucets are working together to help each other, whereas the drain is working against that. All right, so let's look at the part of the job that's completed on per minute. No, yeah, what part of the job is completed on a minute by minute basis? So if it takes 12 minutes for the cold water, during that 1 minute time, its contribution towards filling the tub is 1/12. And the hot water faster, it's no, it's slower. Yeah, no, yeah, it's slower, 18 minutes. So on a per minute basis, it is filling 1/18 of the job. Now, the drain, yeah, okay, it's the slowest, otherwise we'd never fill the tub. 24 minutes, so on a per minute basis, it's emptying 1/24 of the tub. So the first two terms are representing water going into the tub. That's why I've let that be positive. And the drain, that's water that's leaving the tub. Now, if all three of these are working simultaneously, we say that they're working together, but remember the drain is kind of fight going against the grain. But so if they're working simultaneously, um, how long would it take to? Okay, so I don't know. So if I call that x, if x is the number of hours needed to fill the tank with all three, um, we'll just call it working, knowing that the drain is working in the opposite direction. All right, so I have one equation, one unknown, and I can solve for x. So let's get a common denominator. What denominator do I want? Let's see, 12 breaks down to 4 times 3. 18 breaks down to 2 times 9. And 24 breaks down to 8 times 3. So, and I want the x in there, a factor of x in there as well. So I've got the biggest exponent on 2 is 3. The biggest exponent on 3 is, so I have 8 times 9. So I want 72x as my least common denominator. So let's come in with this 1/12 and multiply this by 6x over 6x. Let's come in here with the 1 over 18 and 4 times 18 is 72. So I need 4x over 4x, and then minus 1 over 24, and 3 times 24 is 72, so I need 3x over 3x. And over here, with 1 over x, I need 72 over 72, right? Yeah. So now I have the same denominator in all of the terms. So if I multiply both sides of this equation by that common denominator, all these denominators will cancel. And all I'll have left is the numerator and to do the operations that it says on the numerator. So 6x's plus 4x is 10, and 10 minus 3 is 7. And (72 over 7 minutes). Let's round that to a couple decimals. So 72 divided by 7. If I've keyed things in right, if I've done this right, I'm getting 10.29 minutes. Yeah. And that's with the length of time. Now see again, look up here, I put hours at the beginning. My unit of time is in minutes. Hours is so commonly used that I just accidentally write that down all the time when really I have to pay closer attention. So try to do, you may not make that same mistake because you haven't done as many of these problems. But so be aware of the unit of time. And this was with all three working simultaneously. Both faucets were filling and the drain was emptying. And with those three doing their jobs respectively all simultaneously, I'm getting that it will take 10.29 minutes to fill the bathtub. All right, so hey, I hope that helps, and I will talk to you later. Bye.